Now I'd like to talk a bit about the two proofs that were on the back of the pretest. In those cases, you were given a definition as follows. Integer n is even if there exists some integer k such that n equals 2k. Otherwise, n is odd. So this is really two definitions, one for the word even and one for the word odd. Generally, when I am giving you a definition, that's the definition that you use to do anything else with those terms. So, first proof, prove that 13 is odd. We're going to do this one by contradiction. So, suppose contradiction 13 if it's even, then by the definition, then there is some integer k such that 13 equals 2k. I'm just simply reading off what evenness implies. Then, we have to add our own extra bit, in this case, algebra, to mean that k is 6.5. That contradicts claim k you can't have a contradiction. It must be our original assumption that was wrong. It can't be even. 13 must be odd. And then in this class, we'll usually end our proofs with a little box, although you're certainly welcome to write as well. The second proof, I ask you prove that the sum of two even numbers in this case, we're going to follow the advice that Venema gives us and rewrite this as an if-then statement. So what we're saying is if m and n are even integers, then m plus n, we're going to assume that m plus n is an integer. That's not what I asked you to prove. So, proof. First line of a proof of an if-then statement is going to be suppose, and just rewrite our hypothesis. Suppose m and n are even. Then at each step of the way, we're going to draw some conclusion based on the previous sentence. M and n are even integers by definition of their integers, when we're using this definition, n equals 2k. So you can call them k1 and k2. It's going to use two different letters, k and l, so that m is 2k and is 2l. That's exactly what the definition tells us. I'm going to apply a bit of algebra. By algebra, n plus n, the thing we're trying to show is even. Substitute them in, 2k plus 2l, and factor 2 times quantity k plus l. Since that quantity, k plus l, is an integer, that is this, and we're multiplying it by 2. K plus l is an integer. M plus n, which is 2 times that integer, must be even. We're done. Notice how we start this. Suppose our hypothesis, our last statement is m plus n is even. You always start with your hypothesis and end with your conclusion, unless you're using a contradiction or a proof by contrapositive.